Vanakkam one and all. In the video we will discuss many results based on cos function. Okay, so in the last video we have proved the cos x plus y as cos y cos x minus sin x sin y. Now we will derive results based on this relation. We have proved this in one of the last videos. We will derive few more results based on this identity. So we'll take, suppose in this we will replace y by minus y. So what will happen? Cos x plus minus y we will write, then cos x, then cos minus y minus sin x, then sin minus y. So we will get, here it is cos x minus y equal to cos x. Cos function is an even function, so cos minus y will be cos y only. So we will have cos y minus sin is an odd function, so sin of minus y will be minus sin y. Okay, so minus minus will be plus, so we will have sin x into sin y. So this is an identity of cos x minus y. Now we will look at other one. Now we will see other result. In this I am going to replace x as pi by 2 and y as x. Okay, replace. So the given identities are the proven identity is this: cos x cos y minus sin x into sin y. Now we will replace x as pi by 2 and y as x. So we will get cos pi by 2 cos x minus sin pi by 2 sin x. After replacing we will get like this. Now we know cos pi by 2, that is cos 90 degree is 0. So this term vanishes and sin pi by 2 value is 1. Okay, so we will get minus 1 into sin x. This is nothing but minus sin x. So cos pi by 2 plus x is cos pi by 2 plus x is. So if you write an angle as sum of pi by 2 plus x, you'll be able to write it as minus sin x. Okay, minus sin x. Now say for example, suppose we have cos 90 degree plus 20 degree. So this one will be in the second quadrant. According to the phrase all silver teacups, ಇದು second quadrant sign and its inverse alone positive. So cos ratio will turn into sin and cos ratio in the second quadrant negative இருக்கும். So we will have minus sign. So minus sin 20. This is just an example for this. Okay, so cos pi by 2 plus x will be minus sin x. இப்போ இதே ஐடென்டிட்டியில் நம்ம எக்ஸை வந்து pi by 2 and y வந்து minus x and replace பண்ணா என்ன கிடைக்கும்? cos pi by 2 minus x equal to cos pi by 2, x can be replaced by pi by 2, cos y should be replaced by minus x, minus sin x should be replaced by pi by 2 and sin x will be replaced by y will be replaced by minus x. Again cos pi by 2 0, so this term vanishes, so we will have minus sin pi by 2 and sin minus x. So sin is an odd function, so sin minus x will be minus sin x. So we will have this value, sin 90 degree is 1, so minus 1 into minus sin x. So this value will be sin x. So cos pi by 2 minus x will be sin x. For this we can take this illustration example. Suppose sin 90 degree minus 70 degree. Let us take. So cos 90 degree minus 70 degree. So this angle cos 90 degree minus 70 degree will lie in the first quadrant. So according to the phrase all silver teacups, in the first quadrant all ratios are positive. So sin will turn into cos will turn into sin, and the ratio will be same. You will have sin 70 degree. So this is one of the important results. Now we will replace x as, this x as pi and y as minus x from in the same result. So what will happen? Cos, I am replacing x as pi, y as minus x. So we will have cos pi cos minus x minus sin pi sin minus x. So since sin pi value is 0, sin pi value is 0. Not only sin pi, sin integral multiples of pi will be 0. So this term vanishes. So we will have cos pi into cos of minus. Now cos pi value is minus 1. Cos is an even function, so we will have cos x. So the answer is minus cos x. Cos of pi minus x will be minus cos x. And in the same identity, I am replacing x as pi and y as x. So cos x as pi, y as x. So cos, in this one, cos pi plus x. Again, substituting over the result, we will get cos pi cos y. Okay, cos pi cos x minus sin pi sin x. Again sin pi value 0, so this term vanishes, so we will have cos pi and cos x. Again this cos pi value is minus 1, so we will have minus 1 cos x. So from this derivation we can derive cos n, where n is an integer. Okay, assume n is an integer, n pi by 2 minus x will be sin x, because this n is an odd integer. Whenever n is odd integer and the ratio, the trigonometric function is given in this form, you can rewrite that function as sine function. Okay, and whenever we get cos n pi plus or minus x, okay, we will get the same ratio cos x minus cos x. So whenever it is an odd integral multiple of pi by 2, the sin cos ratio will change into sine, and whenever it is an integral multiple of pi, the trigonometric function won't change, it remains the same. So this is the result we are deriving from this derivation. So we will calculate the given angles by splitting that into two different angles, or the splitting that into a 90 degree plus or minus some angle, okay, to get the required value. Now we will replace y as x. So we will get cos x plus x, which is equal to cos x minus sin x sin x. So this one will be cos square x minus sin square x. We will use these identities while solving trigonometric problem. Now we know the identity sin square x is plus cos square x is equal to 1. We can apply this identity to write this expression in another form. Cos square x sin square x can be written as 1 minus cos square x. So 1 minus cos square x. So cos square x minus 1 plus cos square x. Since these two are like terms, we will get 2 cos square x minus 1. This is another form of writing cos 2x. And we can rewrite this as cos 2x is equal to, we have minus sin square x. Cos square can be replaced by 1 minus sin square x. So we will get 1 minus 2 sin square x. Fine. And in the cos 2x equal to cos square x minus sin square x, where we have the denominator as 1, so that 1 can be replaced by cos square x plus sin square x. Now we will divide this expression by cos square x. Divide both numerator and denominator by cos square x. Abdi pannumbodhu what we will get? Cos square x by cos square x minus sin square x by cos square x, which is divided by cos square x by cos square x plus sin square x by cos square x. So we'll get 1 minus tan square, because sin by cos will be tan. So tan square x and 1 plus tan square x. This is another way of writing cos 2x. Now in the identity we will replace x as 2x and y as x. So we will get cos 2x plus x, which is cos 2x cos x minus sin 2x sin x. Now from the previous expansion, we can write cos 2x as 2 cos square x minus 1 into cos x, and sin 2x can be written as 2 sin x into cos x. So we will get 2 sin x into cos x into sin x. So now we will get 2 cos square x minus 1. Now we will get cos x minus 2 sin square x into cos x. So again this sin square x can be replaced by 1 minus cos square x. 2 cos square x minus 1 into cos x minus 2 1 minus cos square x into cos x. Now I am taking this cos x inside, so I will get 2 cos cube x minus cos x minus 2 cos x plus 2 cos cube x. So 2 cos cube x, 2 cos cube x, together it is 4 cos cube x. Then we have minus cos x minus 2 cos x. So it is, these two are like terms, so this one can be written as 3 cos x. This is another form of cos 3x.